Today we will discuss about smart grid. So before going to the concept of smart grid, we have to know about what is normal conventional electric grid. That means power grid. So this conventional electric grid or power grid consists of three main systems. One is power generation and power transmission and power distribution system. So initially, power is generated at a power generating station, and it is transmitted via transmission lines, and it is distributed to the customers through the distribution line. So the first alternating current power grid was installed in 1886 in the USA. In 20th century, local grids grew over time and were eventually interconnected for economic and reliability reasons. So initially, only one power generating station used to supply or distribute power to the consumers. But in the 1960s, these electric grids of developed countries become very large, mature, and highly interconnected. So now it is uh, all these different generating stations are getting integrated to give the supply to the demand. And initially, there are only thermal power stations were located to the close to the fossil fuel reserves. Siting of hydroelectric dams in mountain areas also strongly influenced the structure of the emerging grid. So, nuclear power plants were sited for availability of cooling water. So initially, only these conventional generating stations are there, like thermal power stations, hydropower stations, and nuclear power stations. Mostly, these thermal power stations are situated at the where the coal reserves, especially fossil fuel reserves, are there. Uh, at that place, thermal power stations are usually situated. Even though it is very polluting and uh, it emits so harmful gases, but it is very economically possible for the huge population to supply power. And in late 1960, the electricity grid reaches the overwhelming majority of the population of developed countries, with only the regional areas remaining off grid. And metering of the electricity consumption was necessary on a per user basis in order to allow appropriate billing according to the level of consumption of different users. Because of limited data collection and processing capability during the period of growth of the grid, fixed tariff arrangements were commonly put in the place, as well as dual tariff arrangements where nighttime power was charged at lower rate than the daytime power. And initial days, the demand is very high and the supply is very low, and these causes power cuts, frequently power cuts, and the pure power quality issues also started rising. And if any fault is come, the due to the due to the electromechanical, the response will be very slow, and the chance of getting blackouts and power outages are very common in the 1970s to 1990s. Towards the end of the 20th century, electricity demand patterns were established. Domestic heating and air conditioning led to the daily peaks in demand that were met by an array of peaking power generation that would be only be turned on for short periods each day. So these are the conventional generating stations initially, and after 21st century, there is an opportunity to take advantage of improvements in the electronic communication technology to resolve the limitations and costs of electrical grid have become apparent. So, a lot of renewable energy sources are came into the picture. So, they started generating the power from the natural resource called sun, and the solar power plants came into the existence. And even the dominant forms such as wind power and solar power are highly variable, and so the need of for more sophisticated control system become apparent to facilitate the connection of sources to the otherwise highly controllable grid. So there is a more of use of renewable energy sources came into the picture in the 21st century, and these solar power plant and wind power plant, initially these uh, sources are the non-conventional sources. Now these becoming as a conventional sources. So, concepts of smart grid. So, what is the smart grid definition? So, smart grid is an electrical grid with automation, communication, and IT system that can monitor power flows from point of generation to point of consumption and control the power flow or curtail the load to match generation in real time or near real time. So smart grids can be achieved by implementing efficient transmission and distribution system and system operations, consumer integration, and renewable integration. The smart grid solution helps to monitor, measure, and control power flows in real time that can contribute to identification of losses, and thereby appropriate technical and managerial actions can be taken to arrest these losses. Simply, smart grid is defined by various organizations. Initially, the smart grid is defined by the IEEE Society. That is that smart grid is a giant system of systems where each utilitarian domain consists of three layers. So one is power and energy layer, and second one is communication layer, and third one is IT computer layer. So they define that the existing power energy framework is made smarter using the other two and three layers. So the normal grid, which consists of power and energy layer, is added with the communication layer and IT computer layer to make a ordinary power grid to the smart grid. So even the US Department of Energy defines smart grid as the grid that uses digital technology to improve security, reliability, and efficiency, both energy and economic, of the electric system from large generation through the delivery systems to electricity consumers and a growing number of storage resources and distributed generation. The State Grid Corporation of China defines smart grid as a strong and robust electric power system which is supported by ultra high voltage network based on the coordinated development of power grids at different voltage levels, supported by communication and information infrastructure characterized as an interoperable and automated power system, and the integration of information and business flows with electricity. And the UK Department of Energy and Climate Change is defines smart grid as it defines grid as a smart when grid uses both the communications and information techniques to the electric power system, which enables enhanced real-time power flows of information within the network and enhanced synergy between suppliers and consumers. So mostly all these definition define only same one point, that is that a smart grid is nothing but a conventional power grid with additional layers of communication layer and IT and computer layer. So coming to the what is the need of our smart grid? So the main need of smart grid is enhanced reliability and resilience. So if you want to enhance the reliability and resilience, so there is some real-time monitoring and control is will be happen. So smart grids can detect and respond to issues in real time, minimizing outages and improving the overall reliability of power supply. And even these smart grids, they can automatically detect faults and reroute and prevent outages, so enhancing the resilience of the power network. And the main other need of the smart grid is uh, it can be useful for the integration of renewable energy sources. So nowadays, people starting using the solar power plant and solar wind and other renewable energy sources at their homes. So these should be integrated to the to the power grid. When we shift to the smart grid, It will be more efficiently integrated with the renewable energy sources like solar, wind, and hydro, mini hydroelectric power, which is much variable and decentralized. And the efficiency also we can increase through the smart grid. So whenever smart grid allows for the demand side management, where consumer can adjust their energy usage based on real time pricing or grid conditions, reducing overall energy consumption. So by this we can reduce the energy loss. The other needs of smart grid are we can empower the customers. So consumers can access the real-time data about their energy usage, allowing them to make informed decisions and optimize their consumption. So they can even limit the usage of their energy if they want to use up to 100 units or 200 units. Then some alert message will come to the consumers and they will decrease the consumption of energy, so that by this they can reduce the bill, that month bill. Yeah, they can interact with the uh, distribution company. And we all even the need of one of the most important need of smart grid is we can improve the grid security. So smart grids incorporated with the advanced cybersecurity measures to protect the all the digital threats. And there is a support of electric vehicles. Even we can integrate the electrical vehicles by shifting to the smart grids. So smart grids can manage the increased load from electrical vehicles, and they can optimize the charging times and locations also. And they enable the use of electrical vehicles as mobile energy storage, that which can provide power back to the grid when needed. And this smart grid also gives the facilitation of decentralized energy system, that means microgrid. So smart grid supports the development of microgrids, which can operate independently or in the conjunction with the main grid, providing the localized energy resilience. So microgrid is a grid that have both local sources and also local loads. And also we can integrate the energy storage devices. And there are some more need of smart grid are there, like we can reduce the carbon print. So whenever we are decreasing the uh, like thermal power stations and all, there is a low carbon emission will be there, and we are shifting to the renewable energy sources, and these are less carbon emission methods. So that's why we can reduce the carbon footprint. And there are some economic benefits also. So smart grids reduce operational cost for utilities by improving the efficiency and reducing the need for expensive infrastructure upgrades. And one more need of smart grid is regulatory and market adoption. So these smart grids enable more flexible and dynamic pricing models that reflect real-time supply and demand, fostering a more efficient energy market. So functions of smart grid. So the first function of smart grid is real-time monitoring. So real-time monitoring is achieved through the advanced metering infrastructures. So these smart grids employ smart meters, which consists of voltage sensor, current sensor, and they will collect the real-time data of energy consumption and provide two-way communication between the utility and consumers. So this enables accurate billing, remote meter reading, and demand response programs. So demand response. So smart grid facilitate demand response programs where consumers can adjust their energy usage based on signals from the grid. So this helps balance electricity supply and demand during peak periods, reducing strain on the grid and avoids blackouts. And the another function of smart grid is distribution automation. So smart grids utilize automation technologies to monitor and control the distribution of electricity. So this includes automated switches, reclosers, and sensors that detect faults and optimize power flow and quickly isolate and restore power in case of power outages. And the other function of smart grid is integration of renewable energy. The smart grid supports the integration of renewable energy sources such as solar, wind. This enable real-time monitoring and control of renewable energy sources to balance the both supply and demand. The other function of smart grid is energy storage management. So these smart grid facilitate the integration of energy storage systems such as batteries into the grid infrastructure, and energy storage helps store excess energy during periods of low demand and release it during peak times, enhancing grid stability and optimizing resource utilization. And the other function of smart grid is grid resilience and self-healing. The smart grids are designed to be resilient to come up from able to quickly recover from faults or outages. Or self-healing capabilities enable the grid to automatically detect and isolate and reroute power from the event called as fault, and also it minimize the impact on the customers. And the other function of smart grid is grid analytics. So in smart grid, we can employ the advanced data analytic techniques like machine learning, deep learning, artificial neural network to the vast amount of data collected from the various grid components like smart meters, advanced metering infrastructure, sensors. So this data analysis helps utilize optimized grid performance and detect faults, and also it can predict the demand patterns and also plan and maintain the infrastructure upgrades very effectively. And other function of smart grid is we can integrate the electrical vehicle as we the electrical vehicle is more and more new technology, and these smart grids play a crucial role in managing EV charging infrastructure. And we can also, the last function of smart grid is we can also integrate the decentralized uh, power system like microgrids. Also, we can integrate microgrids here. So, smart grids can facilitate the formation of microgrids which are more localized. So, it consists of more local sources and local loads that can operate independently or connect to the main grid. So now we will see the difference between the conventional grid and smart grid. So in conventional grid, all the restoration is done through the manual process, and whereas in smart grid, it is everything. It happens through the self healing. So automatically, grid know the position of the grid, know the health of the grid, and if any fault is occurred, it can directly sense the fault and it recover from the fault. And most of the conventional grid uses electromechanical relays, whereas in the smart grid, digital relays will be replaced, and also smart meters will be replaced. And in conventional grid, the control is very limited, and in smart grid, the more control options are there. In conventional grid, the communication is one way. In smart grid, the communication is two-way. In conventional grid, the generation is centralized, and very smart grid, the generation is distributed. In the conventional grid, there are some failures and blackouts, but in smart grid, it is very adaptive, and even the fault is also, if the fault is happened, the healthier zone will be isolated. So the zone will be isolated here. And in conventional grid, sensors are very few. In smart grid, there are more sensors in the grid. In conventional grid, the test will be done through manual check, whereas a smart grid, even we can test the entire grid at remote locations. In conventional grid monitoring, there is no monitoring in the conventional grid, and in smart grid, it is self monitoring. In conventional grid, there is no real-time monitoring. In smart grid, it has some real-time monitoring. In conventional grid, mostly we use electromechanical relays. The reaction time is very slow, whereas in smart grid, everything is digital, so the reaction time is very quick. In conventional grid, we cannot integrate the energy storage, and in smart grid, we can integrate the energy storage. So these are the main difference between the conventional grid and smart grid. Coming to the opportunities and barriers of smart grid. So these the main opportunity of the smart grid is due to the advanced metering infrastructure. So this provide real-time monitoring and information about the voltage, current, frequency, and energy usage of the grid. And smart grids can detect and respond to the outages more quickly and improving system reliability and reducing the downtime. And it also enhance the resilience against the natural disasters and cyber attacks through the better real-time monitoring and controlling. And the real-time monitoring and control allow for better energy management. Therefore, we can reduce the losses and optimize the energy usage. And smart grids also facilitate the integration of renewable energy sources like solar and wind, and also we can facilitate the electrical vehicle and energy storage solution to contribute more green energy ecosystem. And also we can create new jobs in the technology, engineering, and service sectors related to the smart grid development and maintenance. And there are new business models and revenue system also to innovative energy service and products also come into the picture. And the main opportunity of the smart grid is consumers can participate in the demand response programs. Like we can time of use pricing, real time pricing, and other initiatives too. We can save the bills or energy cost to the consumers. And demand response program enable consumer to adjust their usage during peak times, lowering overall energy consumption. These are the opportunities of the smart grid. Even though there are many opportunities in the smart grid, there are some barriers for the smart grid. So the main barrier for the smart grid is initially all these power grids have the old metering infrastructures like electromechanical relays, and these electromechanical relays and the electromechanical relays should be replaced with the advanced metering infrastructures like smart meters, sensors, communication protocols, and this requires more cost. So the upgrading and replacing the old infrastructure can be time consuming, and also it is very expensive. Expensive. So the initial cost of smart grid is very high. So this is one of the barrier of the smart grid. And the other main important barrier of smart grid is consumer acceptance and primary concerns. So some consumers may be resistant to adopting to the new technologies due to the concerns about the privacy, data security, or the complexity of managing their energy usage. So public awareness and education efforts is needed to build trust and understanding of smart grid benefits. And there are another barrier for the smart grid is technical challenges. So the integrating of distributed energy sources such as solar panels and wind turbines into the grid can be technically very complex. And the regulatory and policy changes is also one of the main barrier of smart grid. So existing regulations may not be well suited to the new technologies, and the business models is handled by the smart grids. The lack of standardized regulations across regions can hinder the development and implementation of the smart grid solution. And the other barrier of smart grid is cyber security risks. So whenever we are interconnecting the internet to the power grid, so there is a chance of cyber attacks is much possible. So ensuring a robust cyber security measure is very challenging and requires ongoing investment and innovation. And the other barrier of smart grid is data management analytics. And there are vast amount of data is collected from the smart meters, voltage sensors, and other grid components. So we have to efficiently manage and we have to train in the data management and analytical techniques like machine learning, deep learning, and artificial network. And it is very difficult to handle this huge big data. And we have seen the we have known about the what are the barriers of smart grid. Now we are moving to the concept of resilient and self-healing grid. So coming to the resilient concept of resilient, the ability of a smart grid to resist failure and rapidly recover from breakdown or fault occurred is referred to as resiliency of the smart grid. So a resilient smart grid typically follows three basic steps. So one is it should be very anticipated to detect the faults, and it has to ready to accept the failure. And third one is whenever a fault is occurred, it should grid should continuously monitor the data, and we should be go to the data analytics, and again it should resolve the fault, and then it should isolate the fault area or fault line to the healthier line. So this is the main concept of resilience of the smart grid. And coming to the concept of the self-healing grid, the property of a smart grid that enables a power system to know that it is not operating correctly, and without any human intervention, the system makes necessary adjustments to restore itself to normal operating condition is referred to as the self-healing property of the smart grid. So, in self-healing grid, it is a property of a smart grid that enables a power system to know that it is not operating correctly. So, and without any human intervention, the system makes necessary adjustment to some data analytic techniques to restore itself to the normal condition. And this property is known as self-healing property. So it consists of so many functions like automated fault detection, autonomous decision making, and real time communication and proactive maintenance. So coming to the present development of smart grid. So in India, there are some smart grid pilot projects are going on by Ministry of Power. One is at Asbir, and one is at Assam, one is at Mysore, and another in Himachal Pradesh and Puducherry, Tripura, Telangana, and GD Metla, and Haryana, Gujarat, West Bengal, IIT Kanpur, and Manesar. And these are the different pilot projects is going on. So this is the capacity of the pilot smart grid projects in India. You can see here. And there are another smart grid projects under NSGM is are also going on here. And they are one is at CED Chandigarh, and another one is at JVVNL Rajasthan. And coming to the international policies on smart grid, various countries have different smart grid international policies. So coming to the United States of America, it consists of a grid monetization initiative. So this is launched by the US Department of Energy. So this initiative focuses on improving the grid reliability and resilience and efficiency to the adoption of smart grid technology. It includes investment in advanced sensors, energy storage, and cybersecurity. And there is another policy is there, that Federal Energy Regulatory Commission policies. So this FERC is more uh, it more supports on the smart grid employment to regulation that encourages demand response, energy storage, and development of wholesale electricity markets, and that facilitate the modernization. And coming to the European Union, it consists of Horizon Europe program. The European Union Research and Innovation Funding Program supports these projects related to the smart grids and focusing on digitalization, decarbonization, and cross-border energy cooperation. And coming to the international policies of China, so the smart grid policy of China, so it has some state grid corporation of China initiatives. So China's it is a government state-owned utility, has invested heavily in the smart grid technologies, particularly ultra high voltage transmission, smart metering, and renewable energy integration. So these efforts are part of China's broader strategy to modernize its energy infrastructure, especially modernizing the ordinary meters to the advanced metering infrastructure. And they also have some 5-year plans, like China 14th 5-year plan, some from 2021 to 25. It emphasizes the development of smart grids, including the integration of artificial intelligence, big data, and IoT to the grid management and supporting renewable energy. So coming to the Japan, so Tokyo Electric Power Company (TEPCO), the largest utility company in Japan, serving for 28 million customers, plan to install 17 million smart meters by 2019. And it also has some feed scheme, like new purchase system for photovoltaic electricity launched in the 2019 is a key government initiative for renewable to encourage more renewable energy sources. And Japan Ministry of Economy, Trade and Industry METI is a major government agency responsible for the smart grid development, and its objectives are to enable further integration of renewable energy, facilitate the development of electric vehicles, including the charging infrastructure, and create new services using smart meters and ICT networks. And coming to the South Korea, so South Korea imports 97% of energy it consumes, and it is highly dependent on imported petroleum and liquefied natural gas. So the deployment of smart grid technology started in 2005 when Korea launched the Power IT National program in order to develop digital, environmental friendly, and intelligent electric power devices and systems, and advanced Korean electric power to electric industries. And they also have some smart grid roadmap 2030 is another key step. So this will be implemented in 5 sectors. One is smart power grid, and smart transportation, smart renewables, and smart electricity service. So by 2030, a nationwide smart grid, and 2027, 140 charge stations for electric vehicle will be built, and the penetration rate of smart meters and AMI advanced metering infrastructure will reach 100% by 2020. These are the plans of South Korea. In addition, Korea will also have 11% of energy from renewable energy and achieve its maximum of 10% power reduction by 2030. To implement all these are the policies. They also started the pilot projects. In the first step, they implemented a this pilot program on Jeju Island on June 2009, which is consists of fully integrated smart grid system for 6,000 households, wind farms, and 4 distribution lines. The smart grid policies in Italy. So Italy has one of the largest and most expensive smart metering programs in the world. In regulatory order for 18 December 2016, number 292/506, and regulatory order 26 September 2007, number 235/07. Italian legislators introduced a mandatory installation of smart meters for all household and non-household low voltage customers starting from January 1, 2008, and minimum performance standards for the meters were also provided. So in order to, they also, Italian government also increased the renewable distributed generation. They have some guaranteed priority access of electricity generated from the renewable to the grid, and provided feed into tariffs to solar photovoltaics. The fourth Conto Energia, approved by the Ministry for Economic Development in 2011, provides a differentiated incentive system for solar PV, including a specific budget designed for large PV plants between 2011 and 2012. And coming to the smart grid policies in the UK, the British government has designed multiple institutions and platforms to increase fundraising for smart grid development. A typical example is the Energy Technologies Institute, a partnership between the British government and the industrial sectors. It allows for a variable mix of public and private funding to accelerate the development of low carbon technologies, including energy storage, building energy management, and distribution generation. To modernize and reduce the carbon footprint of electric grids, one major initiative of the UK is to increase the energy efficiency to smart meter deployment. So here also they are using smart meters. The British government expects full penetration of smart meters by 2020, with total financial limits of 8.6 billion pounds, which is estimated to be 13.5 US dollars, and a total benefit of 14.6 billion pounds over the next 20 years. So 42 early government actions can be traced to the 2008 Energy Act, which allows Secretary of State to take measures to install and facilitate the installation of smart meters. So these are the some basic concepts of smart grid. Thank you.